All right, here's practice problem number 7. A planet has a radius of 13,500 kilometers and a mass of 5.3 times 10 to the 25th kilograms. Find the escape velocity from the surface of this planet. Now, so here's the equation, right? The escape velocity. Isaac Newton actually figured this out 350 years ago. The escape velocity is equal to the square root of 2g, big G, which is, of course, the universal gravitational constant, times the mass of the planet in kilograms, right? It has to be in kilograms, or the mass of the object. It doesn't have to be a planet. It's any object that you're trying to escape from and never come back. And then divided by the distance from the center of the planet. In this particular case, that's why it says here from the surface of the planet. R is the distance from the surface of the planet to the center of the planet, which of course is just the radius of the planet. If you were trying to leave the planet from like the top of a mountain, it would be like R plus H, for example, if H was the height of the mountain from the surface of the planet. Just to let you know. All right, so the thing about this is M has to be in kilograms and R has to be in meters, not kilometers. Okay, so they gave us the answer in kilometers. You got to convert it to meters, and the velocity turns out to be the answer comes out to be meters per second. Now, it's very typical in astronomy to change that final answer. Although I didn't ask you to do that here. It's very typical to change this into kilograms. I'm sorry, into kilometers per second. Okay, because for example, to leave the Earth and never come back, it takes about 11. You have to be traveling at about 11.5 kilometers per second. Okay, so we usually use kilometers. All right, so anyhow, I'll show you both. This final answer here, it was just in meters per second, but you just divide it by 1,000 to convert it to kilometers per second. All right, so anyhow, let's do the problem. So we have R. So R is I guess I used. You can use the big R. I guess I used a little r right there. I didn't mean to do that. So it's 13,500 kilometers, right? And I know that in 1 kilometer, right, because it's the metric prefix kilo, it's times 10 to the third meters. It's 1,000 meters, right? So the kilometer part cancels, and so this just becomes. So it would be 13,500, and just add 3 more zeros, and that's perfectly fine. Or you could say times 10. That's the E3. All right, meters. So now it's in meters. Now you're ready to go. Or you could write it. Remember, you could write it like this: 13500. Right, that's the original number, and just add 3 zeros, which is exactly what that is. That's what times 10 to the third is. All right, so anyhow, then we put it into this equation. As long as all the units are correct, the velocity, the escape velocity, S, sorry, that's supposed to be an S. The escape velocity is the square root of 2 times big G, which is 6.67 times 10 to the minus 11th. You're going to use that a lot. You probably have it memorized after. You don't have to memorize any of these numerical values. Times the mass. Let's see. This world has a mass of 5.3 times 10 to the 25th. All right. So that's why we write it like that. It's just easier to write. And then 13. Sorry. 13,500 times 10 to the third. I'll just put the E3 right there. All right. So we're going to plug all that into our calculator, and that will be the answer. All right, or we'll get the answer, and then we'll even convert it to kilometers per second, just for the heck of it. All right, so let's get rid of this. All right, so here we go. All right, so it's going to be the square root. All right, so square root of 2 times. Well, let me see something. No, it's all right. So here, I really don't like this calculator, but I'm forced to use it to show you uh, what I'm doing or what I'm trying to do. Oh my gosh! All right, so the square root of 2. Oh, you know what? It's not going to work. So here, I'm gonna do what's in the square root first. 2 times 6.67. I mean, normally with a regular calculator, you'd just be able to use times 10 to the minus 11th times the mass, which is 5.3, times 10. Remember, you're never hitting times, you're never hitting 10. You have to use the EE button or the EXP button, depending on what type of calculator you have, times 10 to the 25th, divided by, so it's 13500, and I could just type 3 more zeros, or it doesn't really matter. Either way, it works just fine. EXP 3. All right, so it's the same thing. All right, so remember, this is not the answer. We're going to have to take the square root of this. All right, so do that, and then we take the square root. So the square root comes out to be 22,884.9 roughly, right? Because if you round it to one place past the decimal, so that's in meters per second. So if this problem said, and I know on the test it does say convert it to kilometers per second, so you just divide it by 1,000, right? Because there's 1,000 meters in a kilometer. And so this, if we were to round this to one place past the decimal, it would be 22.9 kilometers per second. All right, so that would be the proper answer. So this is the answer in meters per second, and once you divide this by 1,000, then that would be 22.9 kilometers per second. All right, very nice. Pause this. All right, here's practice problem number 8. It says, using Aristophanes' method, or so remember, Aristophanes was a guy who lived more than 2,000 years ago. He was around during the time of the Greeks, and he measured the circumference of the Earth by noting that that there was no shadow inside of a well, to the south of the Nile River, about and then there was a shadow of about 7 degrees where he was, which was in Alexandria, Egypt, and the town where there was no shadow was called Syene. It doesn't exist anymore, but you just basically follow the Nile River down, and he actually paid somebody to count the steps to do this. I'm sure you read this in your reading about this, in chapter 2. Anyhow, so Aristophanes' method basically says the following: if you measure the angle, and you compare that to that the Earth is a circle 360 degrees. So that angle to 360 degrees is exactly what the distance between in the case of with Aristophanes, the distance between Syene and Alexandria divided by the circumference of the world of our planet, right? So that's how he figured out. He actually calculated this. So in this case, it says find the circumference of an asteroid in kilometers if a flag is planted at the equator where there's no shadow, and another flag is planted to 25.3 kilometers. So this is like a little tiny planet. 25.3 kilometers to the north. At the same time, the shadow at that flag that's planted to the north has an angle of 12.8 degrees. And so we're going to round to one place past the decimal. All right. So you're basically given all the information except for C. And so here, let me just write this out. Okay. So this is 12. Oops. Here, let's get this thing bigger. So it's 12.8 degrees to 360 degrees. Sorry, that's supposed to be 360 degrees. Is the equivalent of the distance between the two flags, which was measured to be 25. I'm really messing up here. 25.3 kilometers divided by their circumference. All right, so like if you were to flip both sides of this and solve for C, okay, so C would equal, so it would be 360 times, see, because the 25.3 would be on the other side, so you'd have to bring it over, so it'd be times 25.3 kilometers divided by the angle of 12.8. Right, and they're both, so both of these are in degrees, and so the degrees parts cancel, just to let you know, and so it gives you the circumference in kilometers. All right, and so when you do this, it turns out to be 700. So that that's the circumference of this world, of this. It's like an asteroid. So the circumference, just to remind you, the circumference here is like if you picked a point right here. That's the distance to go all the way around. Now, usually another way of asking this question, and your homework problems sometimes ask this as well. There's a relationship between the circumference of any circle and its radius. The circumference of any circle is equal to 2 pi times the sorry, I'm running out of time. Let me make sure I have enough times the radius is what I was trying to say. All right, and so so anyhow, if once you figure out the circumference, which I did right here, you could figure out the radius of this world, right? So the radius would just be the circumference divided by 2 pi. So make sure you remember that. I think this formula right here is on our equation sheet. At any rate, here, let me get the calculator out and try this. All right, so 360 times 25.3 divided by 12.8. All right, so that should give us our 700. So that's the circumference. And if we were to divide that by 2 pi, all right, so in this calculator, I got to do it in steps. So divided by 2 equals, and then divided by pi. All right, so this would be the radius. All right, so the radius of the world would be here. So this is the radius. I didn't ask this, but sometimes you're asked this kind of thing. Here, let me write it down. So rounding it to one place past the decimal, it would be 113.2. So 113.2 kilometers. All right. So, of course, on Blackboard on the test, you just write the number, right? It would already ask you what it was in kilometers. All right. So the circumference is 711.6 kilometers, and the radius is 113.2. All right, that's it for this problem.